A huge applause for Denis.
Thank you.
Good luck.
All right. So actually, this is the first slide. Thank you, everyone, that you decided to listen to my talk instead of getting some tan on the lake. And let's start. My initial talk was scaling architecture at Lyft, and I decided that we should go just with scalable architecture in general and the practice that we use at Lyft, and not only at Lyft. There's my personal opinion on that. My name is Denis. I'm Google developer expert and working as software engineer at Lyft. And also I have an Android development podcast, but it's mainly in Russian, but we making some episodes in English too. So I'm sure everyone knows that the application usage growing and growing and growing, and more people using their mobile phone, because definitely it's have a lot of great apps inside it. And if you're founder of some company, you definitely want that your app will have billions of users, but you start with something simpler, something basic, and then going with like games, chats, video streaming, and all the stuff inside your single app. And your app should be prepared for that. So it can become huge, and you have to be prepared for that scale. Definitely, as engineers, we can do everything, and we can start from scratch and write a big, cool app initially. But the problem, we need to ship it yesterday. So let's talk about agile. Definitely, if we gonna think about the scale and iterations and evolution, we have to go with agile and do some minimum viable product, right? I'm sure everybody knows this concept, and you started your products as MVP. And definitely MVP is not when you do some architecture like you decide, okay, I'll create a network layer, and after that I'll do database, and after that I'll do UI and publish everything. No. And another way of thinking of MVP, you create like some simple app with a single button, and then you created another app with 2 buttons and another app. So also the bad way of doing MVP. In the image here is the right way of doing MVP. So you have to build some base and improve it and make some evolution changes all the way of the releases. And that's the way that we're gonna talk today. And yeah, definitely it's impossible to be prepared for all the cases in your future, but try to build as less unavoidable trade-offs as possible. Definitely it's like obvious things, but sometimes you, as an architect of the app, you forgot about that. So usually the app starting like single developer or several developers, then growing, like insane amount. Yeah, at Lyft we have like 70 developers, and we hiring more. So like it's crazy. And you can think, what? There's just a single screen with the map. Why you need so many developers? No, it's not the single screen with the map, and it's really hard to build all the needs by business, even by 70 people on single platform. So let's start with a simple product with MVP first. So we will talk about 5 different topics, and we need some superheroes. So Superman will help us with the architecture. Definitely only Superman can help that. And Iron Man is more teachy guy. He will cover the build and CI stuff. For network, we need to do it fast, so Flash. And for everything like dependency injection, all the stuff, we need someone who have some spider web. And beautiful Wonder Woman will help us with UI and design. So let's go with initial decision. Architecture. You can go with multiple activities and views, or you can do single activity with fragments nowadays. But my personal opinion, go with single activity with views. So don't go with fragments and don't go with multiple activities, because there's a single activity approach. It's becoming more popular and there's way much easier to you to make transitions. You have more control over what's on screen right now and how to transit from one state to another, and you can simplify your life cycle. And there's several Google solutions called Jetpack, It's based on fragments, but you can switch to views, for example. There's some community-driven frameworks to implement that on GitHub, and you can go with your custom solution. We will talk about that a bit more later. But the thing that I wanna warn you, if you wanna support screen rotation, you have to deal with activity fragment view wherever you use state. And there's several libraries to handle that. You can go with Jetpack view model, it helps you to save and restore state. You can go with data binding library, but better not to do that. You can use iSpeak, Android state, or other GitHub solutions, or implement manually. It's not that hard to understand how rotation works and how to save and restore the state of the view. But the thing, once you skip rotation, there will be no way back. There is, it's possible. It's so hard. If you have 100 screens and no one of that screen supports rotation, it will be really hard to support. So if your business need in the future, maybe not now, to support rotation, it's better not to ship to user rotation of the app, but still support it and test it, because if there's possibility that your business will ask you to do that in the future, start doing it from scratch. It's super Android specific. How many iOS developers there? Oh, lucky guys, you don't have that problems, but you have Xcode, sorry. So, talking about build, we use Gradle. We publish it manually to Google Play after we finish our minimum viable product. For network, we use retrofit and OKHTTP. We use support library for UI. Nothing cool, nothing new, everything obvious. But when the team starts to grow, you start thinking you need to use some logic. So you can put some logic in a custom views and inflate it in several screens and reuse that logic. For basic app, it's good. And the thing about another MVP abbreviation, model view presenter, you have to do some abstractions. So several ways to do that. The first thing that my advice, no matter you Android or iOS, try to be platform agnostic. Try to put everything away from your framework classes. So if you cannot extend something that framework provides to you, do not extend. And do some workarounds to include inside your platform specific. But for the future, you was today on a first talk about Kotlin or C++ or other cross-platform solutions to write the code, and many of companies struggle because they have a lot of logic inside activities or views or view controllers in iOS. Actually, sorry iOS guys for view controller term. That means for me at Android, at Lyft, we call it view controller to be platform agnostic, but in iOS, view controller means more. So the idea is how to abstract, just to make extended of your sum class and make your lifecycle super simple, like attach and detach. No pause, pause, stop, and destroy, and all the stuff. And it will help you. And if you want to save state, just put some class to save the state and restore state inside your own attach and on detach. And when you swap and when you divide your abstract your classes from the platform, you will be way much easier to test it on JVM if we talk about Android, and it will be easy to use, as I said, simplify lifecycle. So talking about this abbreviation MV something, my personal opinion, MVP is as model view presenter, it's way much easier to implement. It's super easy to understand the concept, but when you start growing, it's hard to structure all these classes and all this code. Your presenter is growing so fast, and there's no single state of the view. You cannot understand what's right now presented to user from your code base. How people come up with the MVVM to understand what exactly right now on the view and to test that state. And there's a single state for that, but there's no, at least in Android, for my personal opinion, there's no ideal framework. Data binding is cool, but there's a lot of issues, especially with multi-module setup. And there's no visible understanding how the state of the view is modify and mutate from one state to another. That's how people come up with MVI, model view intent. And hi to FreeLogix, you have your own solution with that called MVI, RX MVI something. There's also good samples on Android Badu MVI core and Mobius by Spotify. And the state transition is covered, but the concept itself is mind-blowing. Like MVP is everybody understand. MVI is you have to spend some time to understand how it works. It's also popular in web called Redux. And in most cases, you have to come up with manual implementation to satisfy your business needs instead of doing some framework. And there's no actually reason to use the framework comparing to MVVM, where it's really hard to implement your own framework. So let's go further. So talking about build, try to automate publishing to Google Play Beta or Alpha. Prior releases, it helps you a lot to do some testing. So like publish your nightly builds or something to your closer users, to your employees or to beta testers. It will help you to find some bugs and uncover it before initial release and try to do it automatically instead of like every night before you go into home, publish it manually. And one more thing that a lot of people forget to think initially when they just started creating the app is to ask user to force upgrade to some new release, because sometimes there's security problems in your old releases, or server cannot maintain compatibility with old APIs, or for example, if you do certificate pinning for network, you have to force user to update to new certificate, or there's some radical change and you have to shut down old implementation of the app and you don't want to publish new app. So try to make some mechanism of requiring force upgrade as soon as possible. And Google, there's a Google Play in-app updates. As far as I know, it's not still released, but I hope on Google I/O it will be released, and that will let us to show the user inside our app the notification, okay, you can update your app, just click it, and you can do this silently in the background, and you don't have to, and user don't have to go to Google Play, click update. It can be done inside your app. Pretty cool. Hope it will be released soon. So we continue growing, and now we have to move our business logic even further. So from view layer, so we have now some abstracted from the framework view layer, but now let's put the business logic away from the view layer to some use cases, or you can call it service or interactor or model or repository, call it whatever you want. Just the basic idea in any company should be implemented, abstract, and move away your business logic from your view layer. And basically your view layer doing some get some data or get some view state, and your use case send this state and do some processing of user inputs in your business logic classes. I think that's obviously true for you. There was talk by Sebastiano before me that's explain you the value of CI and why you have to care about continuous integration, and now everyone understand that. So what my advice is to do continuous integration checks like detect or or PMD or other lints, Swift lint, and I forgot the names on iOS. There's a lot of them on every PR. So your developers create pull request to the master, and you have to check that everything good, all tests is green, and all static analysis is absolutely agree with that. And why the basic is red on that slide? Anyone have some ideas why the basic checks is a bad idea? Okay, I'll help you. So the basic checks is a bad idea because, for example, you implement some basic checks and you skip I don't know, some deep analysis. Then your app will grow, your code base will grow, and you decide, okay, I have to make my checks more stricter, and you turn it on, and you will find thousands of different warnings that will make your PR red on old code base, and you find, oh, I have to deal with that. So basically, the idea is to make your checks and warnings red as soon as possible, and it will help you not to publish some bad code initially. And yeah, there's Sebastiano who explained all the stuff for you. Sebastian, is you here? No? Coffee, yeah. Yeah, good weather. So, talking about network layer, abstract your API responses. It's also do it as soon as possible. So, for example, at Lyft, there was a story that we had a single response for all application state initially, and then only after several years, backend decided, okay, we have to split to several requests and responses instead of just a single, like, get the state of the app and send it back to the user, to the clients. And on the client side, it wasn't there. It was not like that. So when we fetch some God object with all the state, we split it to different objects and send it to different business logic objects. And when backend decided to split it up, we already was prepared because we have internally another objects inside it. So, for example, you have some network response with success and error, and you can convert it to success and error as different classes. But this is just abstract sample. But the idea is to convert it to some your classes that you control, and you can, and if API will change, you don't have to update your business logic, and because you don't operate with that entities. Network, more. Feature toggles. Thanks Freeletics. you did a great job explaining all the stuff related to feature toggles in the previous talk, and Idar explained everything for you, why it's important, and yeah, this is how it works. And you can come up with some third-party. When your scale of the app is not that big, you can up with third-party A/B test solutions like Firebase A/B testing exactly, and use Google Analytics as analytic aggregator or BigQuery if you're growing, but that will be enough for you on that scale. And my advice, if you do analytic in your app and you have several providers of analytic, don't, like, if you do some user click and you track that click, don't track that click and call like Firebase on click and Google Analytics on click, or another, like, I don't know, up some metric super cool service dot click. Create abstraction and inject that abstraction inside every class and just call them, and you can switch from one analytic to another really easily. And if you in the future implement your own analytic, you don't have to rewrite the whole app. So we growing more and more, and the tasks getting more complex, and the scale affect us. So we want to improve the performance of the app, and we introduce some repositories. And the thing that I want to warn you, definitely you have some cache inside your app, but I've seen tons of applications who use some SQLite-based solutions with the database. Do you really need a database inside your app? I don't think so. For most cases, you don't even need NoSQL solution, or like such a big NoSQL solution like Realm. All you need is just get something from the network and persist it somewhere, store it on your disk. So that's what you can do. So just store your data on your disk and then get it back and show it to user. And don't use some complex solutions for complex queries. For most cases, you don't need any query at all except just get by, I don't know, by network request. You can even go with OHTTP cache for basic implementation. Don't do that overhead. And if we not introduce some solution for callback, we have callback hell, right, on Android. And we need to call Superman, have to call Batman, call back Batman. So RxJava is for the rescue, and it will help us to improve data flow, eliminate callbacks, and help us with thread management. Definitely you can say, wait, there's another solution. So you can go with live data from Jetpack if your app is not that big, but it's not that flexible, and coroutines if you're thinking about future and you expecting to go multi-platform, then coroutines is a great option for cross-platform implementation in the future. So build. You struggle with many features, often block releases, because your product managers requesting to wait till the feature finished and then publish it, but also you have some bugs that you wanna solve and send the bug fixes as soon as possible, and you delay release, and sometimes you're not delaying like for months, and you have several product managers and they start fighting with each other about release. So solution is release train. Yep, what a release trains means. So you can publish your releases every week or every 2 weeks, and no matter what is released or what is finished or not, you just cut your master and send it to production. And same for nightly builds. You do every night, you cut it and send to alpha, and every beta or alpha developers or users help you to find all the bugs. Super useful. And you can ask, wait, but what do you mean master? How we do Git flow? Again, my advice, don't go with Git flow, at least on mobile side of development, and merge everything to master as soon as possible, and master your single source of truth, and don't create a lot of branches that you have then merge, because a lot of people ask me how at 70 developer scale you solve the merge and conflict problem. We don't exactly that problem, because we do everything and merge it as soon as possible. And if something not finished in terms of feature, if we change the button or screen or we do refactoring, we go with A/B testing. So we hide these changes by feature flag. If it's not done, it's just hidden by feature flag. And when it's done, we open that feature flag. That's the idea. But everything already merged. So that's how some sneaky researchers have found in some insights about new features inside the apps. They just reverse engineer that and found, oh, there is some, like, I don't know, I cannot say any sample, but for example, like, there's a bike and scooters inside your app or something like that, but it's not released yet, and that's how they find out. So, about network. We solve the problem with the conflicts, but there's a lot of pain to write by hand all this REST API stuff. It's super boring to do that. And API implementation changing on the backend, and the app start crashing, or you receive some errors because API changed, but you was not notified about that. So the idea is to use API schema and generate API for you on the client side and on the server side. And Swagger for the middle size of the project is pretty good solution. So all you do is just write your schema, like what's in this request is post, this is the summary, this is the parameters inside it, and if something will change it and this schema will be merged to master of the schema repository, your code will generate it on the clients, and clients will be changed immediately, and same for backend. The thing here is to create a cool CI that will deliver updates to you, to your client and to your server side. And that will help you to be synchronized. And it will generate for you even in Kotlin or Swift, not just Java or some other old languages. And we'll generate for you the API abstraction and the object itself requests and responses, and even network layer. And that's how you come up with the thing that you need to test more and more your code, and you need to reuse your dependencies and understand the lifecycle of your dependencies, and you come up with you need some dependency injection framework. And if you're a small company or you iOS developer, you go with something that is like Dagger 1, TwoSpeak Coin, Swift Inject or something. But when you start growing, you have to be sure that your graph is consistent and every dependency is satisfied for every consumer of the dependencies. And that's how you come up with the compile time checks. And I was super surprised that on iOS there is no like standard solution with the compile time check dependency injection, and it's easy to break your app when you forgot to satisfy some dependency and app will crash in a runtime. Am I right? There's no? Or there is some compile time check of dependency injection on iOS? Yep, that's fair. And if we talk about Dagger 2, don't go with subcomponents. I've seen there's new changes in an experimental branch on the GitHub for new implementation of subcomponents, but the way how they implement it right now, absolutely non-scalable solution. We can talk about that after the talk. Routing. So when you have several screens and they need to launch each other, then you come up with a problem that all dependencies for screen A have to be satisfied by someone, and all dependencies for screen B have to be satisfied by someone. But how to do that if they need to know each other? Then there's a router or some other abstraction. You can call it whatever you want, navigator, router, or any other, page switcher, for example. But the thing is to abstract that logic of the switching between different screens and put it in a router, and it will help you to deliver dependencies to your screens downstream. Your team continue to grow, and you find out that you have mixed dependencies, and your screen A use a lot of logic from screen B, and the feature C use all of them, and you cannot divide and you cannot refactor because they were so non-obvious and surprising dependencies. So you have to come up with a multi-module project. Yeah, I know it's like trend of last year or year before last year when everyone decided, oh, we have to split it up our app to different modules to improve build speed. It's not actually true that it helped a lot with the build speed, but it helped you a lot to prevent users, your developers, to use another dependencies inside the classes. And for example, you create different modules and you create application that knows about router, but router does not know anything about implementation. Same for features. They have no idea about each other and they have no about the router who started them. So the logic is easy to refactor, and if you want to refactor router, you 100% sure that it will not affect the features itself, because they're not using that. And if you need some feature shared logic, you can create another module and let feature A and feature B know about that shared logic. No, I have a lot of slides, like 50 more. We should not end as soon as right now. So then you come up with another thing. Your business is growing and you have a lot of features inside your app, and you understand for our users there's different business use cases, like there's a delivery of food or scooters, or I don't know, if you Facebook, you understand, oh, there's a messenger feature, we can split it up, and it will help you to improve the speed of app start, because there's less code that launching in a start. It will help you to deliver bug fixes as soon as possible because there's less features inside the app, and just releases will be faster. So split your APK or IPA to different apps and publish it. It's hard for business to convince that initially, but if you find out like there is different sets of the users, then we absolutely safe to do that. And talking about Android, not go with the flavors. Just use several different applications and application classes, I mean, as a starting points. Because flavors, when the flavor is turned off and you do some refactoring in your IDE, it won't change hidden flavors. So pretty bad. So yeah, split your APK, and it will help you to, each application will be separated, as I said, different application classes, independent DI graph, so you can put your use case specific in dependencies inside your graph, and share architecture and common modules if you need. So we have one application with some shared logic, another application with another feature, and if they have something in common, we can create some common module and let them know about that, because we use single repository for mobile applications, and we can get access to this code base from both of them, but it doesn't mean that it will be available for everyone. So one more thing. So now you have a lot of features and business logic things, and on your screen you have a lot of some small parts of UI, and that's how you find out, like, all right, I have, for example, avatar of the user, and when user click on this avatar, we can let them to change that avatar. So let's split it up to different components. So you start thinking not in terms of the screens of your app, but in terms of the small parts of the screen, and reuse that parts. And that part is a single entity that have their own business logic, their own dependency injection graph, their own UI. And when you divide your app to such small pieces, you can reuse them and put that piece to the different screen. For example, at Lyft, the profile screen that my team doing, actually in my team there's only me as a developer on Android. So there's a lot of levels of hierarchy, and the avatar is like on the 4th level, and it's injected in another set of reusable components and another set of reusable components, and we can reuse it in the different parts. And these components on the same level hierarchy does not know about each other nothing, and if I want to hide some parts of this UI, I'll just create a feature flag and hide, for example, payment, or if I want to introduce new items, I'll add it, and it's absolutely independent to the parent. Parent have no idea how the logic inside this inner components implemented. So we split it to two, for example, different apps, and we have some core engineers that maintain common logic. Then one more advice. If you use RxJava a lot or RxSwift, I'm not sure about RxSwift, but in RxJava you have problem with the throwables. If you throw some exception through the stream, this exception hard to catch. Definitely you can do on error and all the stuff, return on error, but the problem is there's no like compile time check that all throwables is checked. So the bad idea is to go with some class like result, or either you can call it whatever you want, but the idea is a generic class with success type and error type, because through your Rx stream you can send as well as errors and results. So you understand, okay, if it's error, then go this flow. If it's success, then go this flow inside your business logic, because during compile time check, it will force you to cover both of the cases instead of going with exceptions. It's actually really major advice, because I've seen a lot of projects who struggle with that problem. And talking about the build, so now at build we have a problem. We have at Lyft we have 800 modules, and we have to understand who own each of them. So we have feature GitHub feature called file owners. So each module have some list of the owners, and if you make some changes and requesting for PR to be merged to master, you have to get approved by owners of that modules, and it will help you a lot to be sure that all the changes in all the modules is checked by their owners. And on the network side, your app growing and you're not satisfied with this BigQuery custom requests and all the stuff, you come up with a custom analytic and experimentation tool that help you to monitor result of experiments not only on the front end but also on the back end, sync all that stuff and make more configurable experiments. But it's a part of different topic, and I'm sure on the next conference someone from Lyft will or other company will join and explain how we deal with the custom experimentation things and custom analytic and doing all this experimentation. On the server side, we want to change at runtime strings, because when you hardcore your strings in your resources, you deliver it to user, it's great. But on Android, there's a layout inflator, and you can make custom layout inflator that will go not only to resources in r.string, but also go to some your map that you just fetched from network, and check if there's some overrides strings, you can fetch it from here. And instead of getting it from your resources, from hard-coded values. And it will help your product managers a lot, like we're experimenting with some values on that visible for user. Pretty easy to implement, but helps a lot. Also, it's good to introduce to another common shared teams that dealing with the network separately. I will explain on next slides why, and with design. So let's talk about the architecture more. We're almost done. We created a pretty complex product already with you. So feature flags for big features. What I mean, your architecture should be pluggable. So if you introduce some new big feature for your app, like, I don't know, Messenger or support chat or like camera stuff or anyone, it should be possible to turn it off or turn it on, especially because your business go into different regions and you want to specify how your app look like for different regions, and you don't want to publish different APKs for that. All you want to do is just to control it from servers. So think for the future and create your features with the ability to turn them off and turn them on from the server. And you can call it like pluggable architecture, wherever you want. Also think is the scopes. The good sample of the scopes, actually many companies, not only Uber doing that, but Uber explained that really good, and it's really popular and called RIBS architecture. And this is a slide from the open source RIBS GitHub repository. When you have different scopes, like log it in, log it out, and in log it in, or this is just a sample, or like a user receive message from support chat state or any other scope, but log it in is easy to understand. So in log it in, you have several scope of dependencies, and log it out, you have another scope of dependencies, and you provide these dependencies to your features downstream. So like your application, your screens, and your visual view components inside that screens, and you send these dependencies from the scope. And when you switch from one scope to another, you just kill everything from the memory and switch to another one. And that's what I mean by scoped architecture. You can read more about that, and this is the trend that every big company come up as a good solution to scale. Talking about build, even if you are as developer, it's good to look at the Bazel. Before that, there was a bug, and nowadays Uber, Airbnb, Lyft, Facebook use bug as the main build system, but Bazel growing more. And a Lyft infrastructure engineer advised me to strike out bug and just advise go with the Bazel, because it's gonna be mainstream really soon, and it's almost ready for everything, all you need. And why? Why Gradle or original the build system in Xcode is not that great? Because when you have 100 different modules and they depend on each other, and you change one module, all the modules will be recompiled. But you don't change anything that other modules are touching. You just change it, this part of the module, something internally, but not affect public API. But there's no concept of public API in Java or Swift or Kotlin. There's a headers in C++. And the thing that Bazel and Bug doing, they generate this kind of headers, a public API called ABI, and help to understand build system that you don't affect something public of this module, and it will rebuild only internal things. Also, you can reuse build cache. When you have hundreds of different modules in your team and one developer of your team already compiled that, why you have to compile it too? There's no changes, so you can fetch it from your local network and reuse it. Pretty neat. And also you can enjoy the internal repository of dependencies like Artifactory or something. Definitely you can do that with Gradle too. But anyway, you have to implement that when you have some internal dependencies on your server and you don't go to JCenter and download it from slower network than your internal one. With design, finally we come up with design. So in design, there's really cool and really hard to achieve. Not many companies doing that, but I'll show you the product language. What product language means, on your cross-platform implementation, you have the same set of buttons, switches, I don't know, toast, like pop-up dialogues or other stuff, or checkboxes, and they looks almost the same on all platforms, and you don't have to put style to button and like use the button class itself each time when you create new screen. Your designer show you in a sketch, for example, like the name of the style, the name of UI component, and your dedicated team. I say there's a dedicated team for design. They implement all these buttons, all these styles by themselves, and all you have to do is just reuse that styles. You see the style in your sketch and you put it in your app, and it saves you a lot of time and make your design consistent all over the screens. And when you have more than 100 screens, it will help you and your designers a lot. And it also helps to designers to sync between each others, because they cannot introduce something custom. Everything is predefined and they have to discuss with each other, are they really need to introduce some new kind of button or text. We're almost done, I promise. Network. As I said, Swagger is really cool. You can generate you can have a schema of API and you can regenerate it. But gRPC is even cooler because there's same concept with the schema and after generation of client and server logic. But also you can do effective asynchronous communication, use network more efficiently, and you can go with instead of JSON with a protobuf on release builds, and it will reduce the payloads and improve the size of the data that your client server communication needs. And your team continue growing, and the idea behind this grow is you as the architect of the small initial MVP, you have a superhero responsibility and think for the future, not just about the needs of the business for today. And the thing that we come up today after this talk, that every architecture decision will require a lot of time to refactor. So try to eliminate the bad decisions and try to think about not tomorrow, but like 1 year or 2 years in the future, if you understand that this product will be such successful. I hope you joined exactly that teams. And separate core features, separate core architecture from the features by some abstractions. So if you decide to implement another core architecture, you will be able to re-implement that internal implementation and don't affect your features, because when you have hundreds of features, it's really hard to do that. But do not make initial solutions very complex, otherwise you will stuck as just on a prototyping state and never go to release. But on the other side, make your checks strict, as I said, on continuous integration server as soon as possible and write as more tests as possible. And make your decisions possible to be mutate, not just super one-way solution that will not be able to change in the future. Like when you come up with RxJava, think how you can switch from RxJava to something other in the future if you want to go cross-platform. Solid is not just an abbreviation that we know but never do it. No, when at scale of 70 or several hundreds of developers, you have to care about that terms like solid and clean code, it will help you a lot to understand what's going on inside your app and help you to test it. So there's a lot of talks about how to do that. I don't want to talk about that too much, but it's not a joke. And share your solutions and approaches with the world and by joining the conferences and podcasts and all this stuff. And thank you for your time. We've done, and hope you have some questions and we will discuss it after my talk. Thank you.